This week we're going to look at how to solve a quadratic by completing the square. And we will begin by looking at quadratics that do not have a b value, so the b value is 0. So here we can say we have x squared equals 49. Since it does have a power of 2, that indicates that it is a quadratic. That's the highest power. However, you can see that there is no x term. Now we could move the 49 to the same side as x squared, and then from that try to then maybe factor or use quadratic formula. But since it is already just x squared equals 49, if we want to go from x squared to just x, we can simply take the square root of x squared. Now if I take the square root, I need to do it on both sides. And then the x times x is what's going to give us x squared. So this would be x, and then we're looking for what times itself is 49. And here you have to be a little careful because it can be both positive or negative 7, because 7 times 7 is 49, but negative 7 times negative 7 is also positive 49. So the square root of 49 is both positive and negative 7. That means that this graph would have zeros at both negative 7 and 7. So those would be our solutions. Now here we can see that this is not set equal to 0, and it's also not x squared by itself. So I could either set it equal to 0, or I could try to get x squared by itself. It's going to be easier to take it and make x squared by itself, so I will add 17 to both sides, leaving x squared equal to 36. At this point, I would simply need to take the square root to make it an x, and the square root of 36 is both positive and negative 6. So those would be our solutions to this equation. On this one, if I go to move the 4, then I would have x squared equals 32. So I've eliminated the 4 through subtraction, and I've done it on both sides to maintain equality. And then if I go to take the square root of 32, this one is not a perfect square like the previous two examples. So I would just try to simplify it as best I can. So if I go over here and think about 32, it's 2 times 16. 16 is a perfect square of 4 times 4. Since it is a perfect square, I can go ahead and stop, or you may have gone on to 2 times 2 and 2 times 2, or you could have done 2 times 8 and then broken 8 down. Either way, if you do it this way, you'll have 2 pairs of 2s, so you would pull a 2 from both of those out. That's still going to be a 4. The easier way would be to go ahead and stop here where you have a pair, which would be 4s, and then it's still going to be positive or negative 4 square root of 2. If you had done this one, you might have had positive or negative 2 times 2 square root of 2, but these should still be multiplied together. So our simplified answer would be positive or negative 4 square root of 2. And then on this one, if you add 11 to both sides, you would have x squared equals 20, and then when you go to take the square root, x would equal some irrational value, so we would just simplify our radical here. So 20 can be written as 2 times 10 and 2 times 5 there. Since we have a pair of 2's, we can write this as both positive or negative 2 square root of 5. It will always come out of a radical as both positive or negative, so don't forget that part. Now this one, the x term is back. It's not a 0 in front of it, so we're still seeing the x. And so for these, what we want to try to do is we want to try to force them to be a perfect square trinomial. So if you remember the perfect squares trinomial, it's a squared, and then this could be either plus or minus 2ab plus b squared. So we have a perfect square for a value, and the b at the end, the constant is also a perfect square. And then the middle term should be the product of both of those twice. Now, if we're looking here, x squared is a perfect square, but 33 is not. So the first thing we would want to do is go ahead and eliminate the 33. So I'll add 33 to both sides, and now I would have x squared plus 8x equals 33. This gives me the opportunity to force it to become a perfect square. So I would want to think about what value would I need in that c term so that the square root of it times the square root of x squared would make it a perfect square. So x squared we already know is going to be x. And we already know it's twice. So we're going to take this middle term 8x, and we're going to divide that by 2 because this was multiplied by 2 in the middle. It appears twice, and that would be 4x. So we already have the x from x squared, which means we need the 4 from our c value. So 4 squared would be 16. So this should be a positive 16, so that the square root of it is 4. So we would take the 4 and square it because it's b squared in the problem. So b is 4, but b squared is 16. Now this is a perfect square, and I could write it as x plus 4 times x plus 4, or x plus 4 squared equals 33. And the reason that we would want to do this is called completing the square, because it was not a perfect square, but I have completed it to be a perfect square now. It is. And but it's not set equal to 0. So this isn't something that we could use factoring on, and it's not something we could use quadratic formula on. But what we can do is we can use a square root here. So if I take the square root of x plus 4 squared, then I need to take the square root of 33 as well. Well, the x plus 4 is multiplied by itself. So this side would become x plus 4 is equal to the square root of 33, and whatever comes out of that is both positive and... So we forced it to be a perfect square. We wrote it as a perfect square binomial, and now we're taking the square root of it. Once we're to this point, if 33 were a perfect square itself, then we could go ahead and simplify that. 33 is not, nor will it simplify, I don't think. So 33 could be written as 3 times 11, and those are both prime. So this doesn't even simplify. So the only thing I need to do now is get rid of this 4. So if I subtract 4 on both sides, and I would put this in front. So we would say x equals, and then negative 4, since we're minusing 4. And I do that because I want to say it's plus or minus the square root of 33. Instead of plus or minus the square root of 33 and then minus 4. I just feel like that looks a little weird. So I like to put that constant in front. So this would be our solution. We could have taken this and used quadratic formula if we wanted, but when it's just x squared and your middle term is even, completing the square is a good option. So here I have x squared minus 6x minus 8 equals 0. It is not currently a perfect square, but it could be because my middle term is even and my first term is a perfect square. So all I need to do is figure out what that third term would be to make it perfect. So the first thing I want to do is start with a clean slate. I want to get rid of the current c value. So I'll add 8 to both sides. Now that I don't have a c term, I want to figure out what c would need to be so that x squared minus 6x plus whatever c is would be a perfect square. So I'm going to take negative 6x, and I'm going to divide it by 2, which would be negative 3x, and that's just because of it being doubled in the middle. The x is already there from the x squared, so I don't have to worry about the x. So I'm going to take the negative 3 and square it, which would be a positive 9. So I'm going to bring in 9 on both sides. That would make it x squared minus 6x plus 9 equals 17. Now it is a perfect square, and so I could write it as x minus 3 squared. It would have to be subtraction to match the middle, and that would equal 17. And then from this point, I could take the square root of both sides. So I would have x minus 3 is equal to positive or negative square root of 17. 17 definitely will not simplify. It is prime in and of itself. So that's the best I can do with that. And then I'll add 3 to both sides. So x will equal 3 plus or minus the square root of 17. And I could have done quadratic formula. This one would not have factored since it has that radical in it, but quadratic formula would have worked. This is just another option for you to have in your tool belt. So for this one, we have x squared plus 12x equals negative 11. Since it's just x squared, which is definitely a perfect square, and 12x is even, I could create a perfect square out of this. Honestly, as long as this is, the first term is any perfect square, you can use this. But if it's not a 1 coefficient, it's not as simple as it would be just to use quadratic formula at that point. So personally, I would not use this unless it's just x squared here at the front. So your a should be 1. So if this one's not even set equal to 0, I could add the 11 to both sides if I wanted to do quadratic formula. But this is perfect for me to try to do completing the square. So I'm going to take 12x and I'm going to divide it by 2. That's going to be 6x. The x is going to be taken care of from the x squared. So I need to take 6 and square it, which would be 36. So I'm going to add in 36 to both sides. And it's perfectly fine to do this because I'm doing it to both sides. So I'm maintaining equality. That's going to make this side equal to 25. Now I can write x squared plus 12x plus 36 as a perfect square. This should be x plus 6 squared, and that would equal 25. At this point, we would take the square root of both sides, and that would leave us with x plus 6 equals positive or negative, and 25 is a perfect square, so this would be positive or negative 5. Now what we need to do is subtract 6 to get x by itself. So x would equal, you have two options here. You can either have negative 6 plus 5 or negative 6 minus 5. So if it's not still a radical, you should go ahead and can simplify further. If it's x negative 6 plus 5, then x would equal negative 1. And if it's negative 6 minus 5, then x would equal negative 11. So those are our two zeros, negative 1 and negative 11. So this is the process of using completing the square, or just using square root if the b term is 0. And I hope that this is helpful for you on some of the problems to decrease the amount of time it takes to solve them.